Thank you. Hello, everyone. Thank you for coming to this talk. We're going to talk a little bit about what it means to do detection at scale. Actually, hyperscale, sorry. They told me if I put hyper in front of it, it's going to be even better. But first, obligatory introduction. Who am I and why am I talking about this? So my name is Domagoj. I'm originally from Croatia, and I'm currently security engineering manager at Google. And I had a lifelong interest in security, as I'm sure many of you had. Started doing security somewhere in high school or so, finished university, and shortly after university, like 2 or 3 years after, I started in Google, and basically I was there ever since. So I've been with Google for 12 years, and it's been quite a privilege. This is not going to be like a detailed talk about my life journey, but if you're interested in some of the experience over those 12 years, you can catch me up later around the conference. I started as an engineer, IC in security, and I worked in the detection and response organization. I stayed in the detection and response organization for those 12 years. So my journey, pretty boring in a way. There's nothing special here, pretty smooth sailing, but I really enjoyed it. There is a little bit of a change that happened somewhere mid those 12 years. I kind of stopped counting. I became a manager, so this is my newest kind of skill, people management. These presentations is supposed to be a little bit technical, but if that doesn't work out, I can always start talking about roadmap prioritizations and performance management techniques. Happy to do that as well. So that's me. That's a little bit of an intro. I will try to keep this talk also a little bit shorter because I would actually like for you to ask me questions. So this is I am hoping this can be a little bit of a live Ask Me Anything session. Let me introduce you to Google's detection and response or security organization in general. Just briefly, what is our mission? I think it's not surprising that we will find that our mission is to protect, respect, and defend our users, Googlers, and the internet. Actually, in my own team in detection, when we say users, we mean Googlers, we mean external users. For us, everyone, we need to protect everyone. That's our mission. Of course, in Google, many different teams contribute to this mission. Google has a bigger security organization with many different moving parts. Detection and response is just one sub-organization, and inside detection and response, many teams contribute to that mission. We have digital forensics, incident management, and so on. This talk is going to be mostly about detection, but of course, we can't forget our partners. The way we approach this problem space from like human perspective, our engineering and operations are combined in one role. So security engineers in detection and response, specifically in detection, they both do operational work, they both do engineering work. So this is kind of combined, two sides of the same coin, and being excellent at both is crucial to general success and being able to deliver on a mission. Of course, we are not alone. Strong partnerships within the company are essential to our success, and you will actually see this, what I mean, shortly. Most notably, partnership with our software engineering organizations. We have a lot of software engineers in Google, as you can imagine. Some of those software engineers are exclusively dedicated to building security infrastructure that then we use to protect the company. That partnership is critical to our success. We spend a lot of time on this, building that partnership and working together. So all those contribute to our general overall mission of detection and response. So, why is it a problem to do kind of detection, intrusion detection at scale? Well, I think it should be kind of obvious, the huge amount of variety you have to deal with every single day. Like everything can happen at scale when you have thousands of machines, hundreds of thousands of endpoints you're monitoring, millions of endpoints you're monitoring. Among millions of endpoints, thousands of them have a bad day every day, right? They're broken, something's wrong. Behaviors you think should never happen, they happen daily because this is just basically a statistical certainty. If you start designing your rules by this only happens if an attacker is in the network, guess what? No, this happens basically every day. Turns out employees do weird stuff. Turns out the combination of all these different systems, when they combine, some weird stuff pops out. And of course, things go completely bonkers all the freaking time. For detection org, having logs is, your bread and butter, but then you have logs arriving in the distant future. You have logs arriving from the Middle Ages in timestamps. How do you deal with this? You have logs that have arrived and should have arrived constantly all day, every day. So that's the challenge of being at scale. You just have to deal with pretty much everything at the end, because when you connect the dots, the logs, you basically oversee the company in a way through its own logs, and then you have to figure out, okay, what actually makes sense here and how to deal with this. There was a great talk today about metrics and how metrics can be misleading, so I thought I should put some metrics here for all of you. Just kind of quick stats to give you a sense of the scale, maybe a little bit of a bite into it, of what we have kind of deal with. So in terms of data sources, or if another way you want to read about this is kind of logs that we have. On the order of 500, this is a little bit outdated, on the order of 500 or more different types of logs we ingest just to make sure we can cover different threads for different surfaces. This kind of, in raw metrics, this would translate to currently around 7 trillion log lines per day, if you want to think about each individual log lines that we have to process and inject to protect the company and write our rules. These things that were struck through, those are in billions, like we had 120 billion over a couple of years, then it grew and it constantly grows. So this is like to give you a little bit of a sense that it's never static, right? As the company grows, you have to kind of adapt to that. If you want to think about like services and applications that we monitor in the orders of thousands, Google also buys a lot of companies, as I'm sure you're familiar. We are also responsible for protecting them. So each and every company is basically a completely different architecture, completely different systems they have, and we kind of have to kind of integrate and monitor them. So there's another dimension to the complexity and the scale. So we have 50 different types of acquisitions. We call them acquisitions that we monitor. In terms of data processing, what do we do to kind of combat that? We have around 1,200, even more rules. I actually don't know the exact number. Still, I'm a manager. I don't need to know that. Luckily, there is a lot of kind of internal technologies we use. Of course, we have our own end agents that we roll out to have a really healthy telemetry. We use machine learning. If you're interested, yes, of course, we use it. All kinds of statistical analysis to do lie detection. We use plain old manual hunting. We have our security engineers who really know how to dig in, go into the logs, go into stuff and find badness and attackers, just by like being very creative and exploring data. And we have a lot of automated systems that process all of this. So this is like the second part of the slide. On your right side, it's a little bit kind of gross simplification. Say we have 1 million events per year. Yes, many of them, of course, are handled completely automatically. We have these automated systems in place which kind of analyze those events. They decide on the badness. And then some of the leftovers is for security engineers, security analysts. They look at that and then they make final decisions if something is really bad or no. And if it's an incident, then we have, of course, the incident management procedures that we do handle that as well. So this, I hope, gives you a little bit of a sense of what's the scale and what are we dealing with. So given all of this and all the problems we have, how do we tackle this? How do we approach this? And this is also part of my journey at Google. A couple of years back, we ran into an issue that we actually had trouble scaling with our new detections, new rules. How do we actually answer to like the growth of the company? How do we answer to covering for more threats? Because our systems were not as good. So we really sit down and we really thought about like our detection and how we want to make sure we are sustainable for the future. And I'm going to start here kind of very philosophically, and I'm going to immediately jump into some code examples. So this is going to be like a really interesting jump. But from the philosophical perspective and kind of pillars of detection at scale, we devised kind of this in three big buckets or three big pillars. First is modeling. Given all the problems like that you have with all your logs and all your data sources, you just cannot leave them lying around like that. You need to take active control over this, and you need to do a lot of data modeling to represent domains that you want to protect. And this is where we invested a lot of energy and a lot of resources. And this is like the key, one of the very, very key aspects of what it means to do a security engineering work at Google. You have to like look at data sources, telemetry you have, and then you have to model that into abstractions that represent your world on top of which you will build your rules. And those abstractions then represent a distance from the raw logs that enables you to maintain them easier, that enables you to scale. And this is like one of our pillars. Second one is intent-based detections in terms of when you write detections on top of logs and things like that, often you run into issues that you actually have to like wrangle actual data sources. You have to think about how is the data processing pipeline working? What do I need to do to make sure that the pipeline or the query finishes or things like that? All non-scalable for security engineers because you don't have time. This is not like what you should be thinking about. You should be thinking about how do I actually find the evidence of bad behavior in the pipeline. So we have invested a lot of time and energy in actually designing a system that has a unified API for security engineers that can use it to express their intent. What is actually you want to detect on top of your abstractions you modeled earlier. And then equally important context, bringing in relevant information, adjusting the time when needed. You cannot make automated decisions if you don't have information. Integrating with key information resources and key information sources in your environment, in your company is critical. Simple example, asset inventory information, HR information, and things like that. Pulling that in when you have a detection, enriching it, and then making additional conclusions is the way to scale. And those are like the three philosophical pillars of our detection that we want to build. And we invested a lot of time in partnership with our software engineers to actually build those systems that hopefully enable us to do that. So let's jump quickly into the example of code to see like how this works. The code I'm going to show you is mock code. Obviously, it's not how it really looks, but it's actually not that far away as well. It's a little bit simplified for the purposes of this presentation. And of course, we're going to start with back in my day. So when I started, we were obviously writing rules, right? The way we were writing rules then was like this. It was a little bit more complex, but basically we were writing a large amount of SQL queries. Almost every single SQL query was one detection rule, you can think of it. And any result, when you run this detection rule, you get some results. When you run the query with results, you can consider this like a detection, something bad happened. In the most possible trivial rule you can possibly imagine is like written up on the screen. This would be like the basic thing. You try to query your execution logs to find a case where your hash matches a virus total hash that has a no bad signatures, right? And then you're like, okay, I want to detect this. So we wrote rules like that, obviously. It was very painful. So there's a couple of problems that I outlined with this that really prevents you from thinking, how can you like expand this? First and foremost, these are all just strings most of the time because we used very simple logs parsing. Like you have host is just a string. Guess what? You have 100,000s of hosts. They don't have unified names. You can't like rely on this. So UID, file path, arguments, these are all just strings basically. It's hard to compare them. It's hard to reason about them. Doing any kind of advanced data processing, not easy. Then when you want to join across different data sources, like in this situation, you have to know joins. You know how SQL specification and any SQL documentation of its implementation, especially internal Google tooling, has hundreds of pages. Well, our security engineers knew what's on the last page of those specifications. And that's not good because then you have to spend time like really wrangling like with the super detailed aspects of how do you like join this data. This is very trivial join. Of course, you have to have more complex joins for more complex rules. Then you run into performance issues of those joins. Like this is not a trivial thing, and maintenance burden on those rules is immense. And then finally, what I also know, basically through those SQL operations, you're just hiding your intent, right? You don't know what this rule. Somebody comes in later, wants to read it, wants to modify it. Is like, okay. Yeah, I have to understand this complex join. Why is that here? What is this telling me? What's the purpose of this? Of course, no documentation ever. So it's very hard to have clean documentation even at Google. So what do we have today? And why do we think this is much better? So our rules today look more like this. Again, not exactly, but closer to this. Of course, protocol buffers to save us from all of this. Basically, if you look at here, this is like an analog of the previous rule. Here we have execution event. This is like a strongly modeled, strongly typed domain that I was talking about before. You invest in this, you model this. This is things that security engineers have decided that this is how data structure should look like. Those are all strongly typed data structures, right? You can see that they contain additional data structures. File path has its own primitives. Machines have their own primitives. like the host identifier. Then to the host identifier, you can attach different operations that are only specific to those hosts. And basically, you're using kind of very normal software engineering principles to model your domain. And every single execution event, of which there's like millions and millions per second, they create one of these messages in a storage. And then on the right-hand side, this is the processing pipeline, and this is the API. This is this intent-based API to write your rules. So you use something like this to express your intention, and it's much easier to reason about. Like, you just write logs.execution events. That's how you read execution events from logs. You don't know what they are. The platform automatically handles late arriving logs, early arriving logs, overlaps in the logs. You don't have to think about any of this. Really, really focus on your intention. You want to implement some filters. You want to implement some enrichments. This is like putting those enrichments into the moment to make sure your rules are high quality, that you can bring in data. And then you can just kind of output those rules as another, we call them facts. These facts in themselves are also structured, so you can build on top of facts. So they are like recursively structured, and then you can compile more complex rules. So you can model your rules from base facts into the more complex facts, and then output alerts for if there is really something bad happening. And this is now serving us really well. It's kind of solving a lot of these maintenance issues, maintenance problems, looking back for things. You don't have to think about it. It really enables you to scale. It's a lot of investment, but this is like bringing this, reducing the gap between software engineering and security engineering. Like bringing those things together is something that really kind of enabled us to really push the needle and move forward. And that's it. That's what I wanted to tell you for today. A little bit of code, a little bit of philosophy. I think I hope I made some points. Guess what? This thing is not perfect. It doesn't work perfectly to migrate this satisfaction. So we need smart people, and we are hiring. So there is a Google booth. Visit us. You probably want to meet Juan there. He has some things for you. I invite you to spend some time with us there. I can go in more details or whatever you are interested in. If you're interested in my path in Google, if you're interested in technologies and technical details, happy to talk about this. And now I would like for you to ask me questions. I believe we have like 10 minutes or so. I'm going to answer. Yeah.
So you said that this approach not working perfectly.
Correct.
What's the main challenge to have this new model?
I think currently the main challenge is more in terms of like, how do we even expand it further? How do we integrate it with, AI, which is coming definitely. And we see some of the gaps here of like, what's the next thing? We need some smart people who can think about that as well. So that would be one of the challenge. Another challenge is those are like when you think about how do we do end-to-end testing of these things is a little bit unexplored area, underserved. We want to invest more there. Like when you think you have these big rules, they detect some threats. Okay, how do you know they actually work, right? This is a very interesting thing. So we would want to invest there as well. So those are like examples of those things. Yes, that's a big, I'm going to go back here. That's a big advantage of this. So see this, like, for example, execution event. So when we acquire another company, and let's say that company has some other agent on the endpoints that's logging executions, the only thing we need to do is create a specialized parser that translates that to our execution event. And then every single rule that relies on our execution, like any rule that covers the executions, will just work out of the box. Sometimes we have these funny moments where we start seeing logs flowing and actually triggering rules without we forgot to send an announcement that we onboarded a company because the pipeline is already ready and it's just automatically doing this. Before that, this would be a nightmare because for every single company, we would have to actually duplicate the rules, tweak them a little bit for every single escrow query, tweak them and say, okay, now this set of rules works for this company, right, for this acquisition. That was like immense. Every other additional marginal cost of an acquisition was huge on our team and on our resources.
What are Google doing to stop use of Google infrastructure against other enterprises, whether it's staging malware or C2 infrastructure or Gmail to attack phishing emails?
I can't answer you that question completely. Google has a lot of like different teams and abuse teams that deal with abuse. They are like doing all kinds of crazy stuff, advanced stuff to fight that. That's not kind of my area, so I won't comment further. Go ahead.
How did the transition from the SQL to this happen? Was it a very long time? Did you in the back and switch?
Oh, I wish we could have flipped the switch. Yeah, it required serious engineering, a serious dedication, serious support from obviously leadership. It was like, it took like a couple of years to build those systems and do the migration. It didn't come for free, for sure. Go ahead.
For people running detections against like GCP kind of thing, like what kind of, like what would you say seems like top things that customers should be kind of aware of, like when you're using Google?
You're asking me like from customers' perspective?
Yeah, because presumably you've got a lot of exposure to different detections. Presumably some of those detections are like detecting kind of mistakes that you may be using.
Yeah.
What are some of the stuff that the classic things that you get wrong?
I can't say what are like the classic things people get wrong with GCP. I don't think I can comment on that. But what I can say is for all of our customers, don't worry, we got covered. We are, I mean, for real, our mission is to protect the entirety of Google, to protect its production infrastructure. By extension, we protect cloud and by extension, their customers. For example, we have rules that can detect sandbox escapes from GCP and so on, so that protects everyone. So I don't know like what actually would be mistakes that customers doing. You want something?
If you ask a question, I owe you a security key. Feel free to stop like Google because I ran out of security keys. But we have more after.
Question there.
When you guys bought an image, did that keep inside in that
Yes, I'm pretty sure it did. I'm not directly like working with that relationship, but this is invaluable information, invaluable partnership for us. Yeah.
Setting up viewing operations to one single role. How do you balance that role between?
Yeah. It's an art. I can say that. It gets difficult from time to time, right? Because operations is driven by interrupts work, by like these priorities. If an incident comes up, if a urgent thing comes up, you have to do it. And engineering work requires more like sitting down, thinking type of things. We have devised like a lot of team structure and a lot of our protocols around this that you have like scheduled on call so that you can plan ahead, you know when you're going to be on call and so on. There is like, Google has invested a lot into our team. I'm really happy for that because then we have like a follow the sun model, obviously, so that people have like normal working hours and normal on-call hours. So this really requires like a good partnership with leadership and engineering to kind of put that structure in precisely that you can kind of manage this. But we think that is invaluable, like for us, because being in touch with operations and doing those incidents, doing those alerts, and then it informs your engineering and vice versa. Go ahead. Yeah.
The GUI app on screen seems to be optimized towards stream filtering.
Yes.
Did you face any challenges creating detection rules that involve multiple events over time?
Yeah. Great question. I wanted to put it in the presentation. I didn't know how it's like gets into real details. This is just one pattern that API supports. We have multiple kind of patterns that we use to break out the domain. One of them is, for example, correlation pattern. We can correlate different events in different time frames. There is different patterns that we kind of support that you can use to express your intent. Go ahead.
So similar to this question, in the first example, everything was powered by SQL. Here we see the beautiful syntactic control around it, which is what kind of resources are
Yeah. Yeah, I actually don't know fully the correct answer here. Even in the first example, SQL is just a language. The implementation was, we do rely on fundamentally like Google data processing technologies. So those are like internal data processing engines that run these things at massive scales, where actually they go and actually read logs from their centers. How that plumbing works, this is like even 2-3 layers below. So what you're seeing here is this is API that security engineers use. Those API gets translated by our platform into those instructions that Google's data processing platform understands, and then data processing platforms go in and do their magic basically for us. This is another big thing. We rely heavily, obviously, on Google's immense experience and skills with processing huge amounts of data. Unfortunately, no. You can implement the API first for yourself, and then you can run it. Go ahead. I don't think I understood the question correctly. Are you asking if this is publicly documented or? Yes. It's not publicly documented. It won't be, unfortunately. Sorry. And this is like I'm giving you a little bit of a simplified version here. This is internal stuff. What would be the crossover? I think that, for example, Splunk API is like the way you do searches in Splunk, and this is more oriented towards text-based searches, and this is not. So there is a little bit of a significant difference here. Go ahead. Good question. I think I can say that detection org around the world is like 130, 40 people. This covers entire company, and then like obviously we have different offices in Europe, in US, in Sydney, India. Like there is like all offices around the world. The teams in the offices are a little bit smaller. Yeah. Go ahead. Sorry, it's a little bit complex question. Maybe you can talk to me a bit later. I kind of didn't follow all the question. All right. I think this is like final question. Go ahead. Sorry, what kind of? Advice, get good at data analysis, understand how to do this, especially at scale, and do some coding. Those are really critical skills, yeah. Thank you.